So what we're going to focus more on today is how we design IoT systems and how we design IoT solutions, namely. If we focused on protocols and communication aspects and communication layers in the last lectures, now we're gonna bring all these things together and talk a bit more about the design methodology that is applied when you are dealing with developing a new IoT system. So we're gonna go through a few steps in order to actually achieve our goal today. So we're gonna start from the purpose and requirements to the IoT system itself. Then we're gonna go through what's called the process model specification, where you define the use cases for your application. Then you're going to refine this and move into the domain model specification where you define entities, devices, services for the IoT system. We're going to move then to another layer where we're going to specify the information model, which is the structure or how the information is structured in the IoT system. Then we're going to go to a layer of service specifications where we're going to map the processes and the information model to specific services and define these specifications for the IoT services. We're gonna go next in another step to the IoT level specification, and this is gonna take you back maybe to the lecture that we had last week, and just apply one of those models to what we're gonna talk today and the application that's gonna be relevant for the IoT system that we're gonna design today. We're gonna then move into a level where we define the functional view, or how we map the IoT level to functional groups. Operational view specification next, where we define the communication options, hosting, storage, and all sorts of other device specifications. Uh, Device and component integration deals with how we integrate the devices and develop and integrate the components, as its name stands. And then, last but not least, the application development itself. So there's a few steps that we need to go through in order to actually achieve this full design methodology process. Now, this is a very, let's say, formalized process. You don't necessarily need to go through all these steps when you are dealing with an IoT application, but it really helps when you want to really formalize the process and you want to actually get very rigorous about your design. This process actually makes sure that you're going through all the levels and you are not missing any types of services, any types of systems. You are mapping exactly your application to the specific technologies that are available. So let's go through each of these steps and see maybe in more detail what each step does in this design methodology, and then we're gonna apply the model to a very simple application. We're gonna want to control the lighting in a house. So we're gonna map all these levels to a very simple application, which is probably going to give you a better feel of how the system works and how you can apply this formal process in order to develop any IoT application. Not necessarily a very simple one, but you can actually apply it to a very complex system as well. So in step one, we're gonna go through purpose and requirement specification. So we define of course, the purpose and the requirements of the system in general, and these might actually compose of the requirements for data collection. How much data does the system need to actually collect in order to make it relevant to do some analysis on the data, and system management, how you actually define your data privacy and security. Also, it's done at this level, and you define also the user interface requirements. So these are, let's say, the basics of step one of the purpose and requirement specification. Step two is the process specification itself, where the use cases of the IoT system are described in a very formal manner. So you are basing your description and you're deriving it from the purpose and the requirement specification. So from step one. Step three, you go through a domain model specification where you describe the main concepts, entities, and objects which are in the domain of the IoT system to be designed. So basically, you define attributes for objects and relationships between those objects. You're basically gonna draw what's called a UML chart for your system. Uh, if you're familiar with it, then it's going to be very easy for you to actually define those components because you're going to provide basically an abstract representation of these concepts of your objects and your entities in your application, independent of any, let's say, specific technology or platform. So you're not going to be relying on a specific technology for a database or for web hosting or for, I don't know, a specific REST protocol. You're just going to specify the concepts and the objects in your application, and then you're going to link them in this UML diagram. With this domain model specification, you can actually go and map out different technologies to this state level diagram that you're gonna have. So it's very easy to understand the IoT domain when you have this domain model specification done. Step four, you define the information model. So this is the structure of all the information in your system. Examples might be attributes for your relations between different components, virtual entities, and so on. So the information model does not describe specifics of how the information is represented or stored. You don't actually describe, in detail how you're gonna achieve storage for your database or your web storage or so on. Uh, we just list some virtual entities that are defined in the previous step. The information model adds more details to the virtual entities. You're going to define their attributes and their relations. So you're going to refine a bit the model in this step. Step five, you define the service specifications. These are all the services that are going to be used by your IoT system. So you're becoming a bit more specialized here. You're going to start to map these services into different types. You're going to categorize them into inputs or output services. You're going to define endpoints for your services, maybe schedules, maybe preconditions, maybe their effects. So you're gonna try to be as descriptive as possible regarding different services that are gonna run in your IoT application here at this level. Uh, in the next step, you're going to define the IoT level. So these are the levels 1 through 6 that we've talked about and we've covered in our previous lecture. You're going to map out according to your requirements set out in the previous steps, and you're going to select one of these levels. If you remember, these levels were from a very low complexity level one, to a very complex level 6 IoT model. Then using that, you're gonna draw what's called a functional view specification. That's a grouping of all the functions of the IoT system, and they are held together in a various, into groups. You can actually define a functional group for all of them or different functional groups for them, depending on their type and depending on how we classify them basically. Each functional group will provide functionalities for interacting with these instances of concepts. defining the domain model, or you can provide information related to these concepts. In step 8, you're gonna go and define the operational view specifications. Uh, these are various options pertaining to how the IoT system is deployed and how its operations are defined. So here you're gonna get very technical at long last. So you're gonna have service hosting options, storage options, different devices that you can use to implement your IoT application, application hosting, and so on. So this is where you're gonna map out the concepts to actual uh, technology pieces that you can actually use to implement your application, and different technologies that you can actually employ to work together to define your application. Last steps, in step 9 you integrate devices and components that you've defined, and in step 10 you're going to actually develop the IoT application. So step 10 is actually the proof of the pudding. You're gonna want to employ all your knowledge that you've actually described in the previous steps to actually make the application work. So I know it's very abstract, it's very high level. So let's go through these steps in an actual example. So you're gonna have a kind of like a case study here that we're gonna apply all these concepts, and it's home automation application, which in the first step, we're going to define the purposes and requirements for this home automation application. It's, as you can see, it's a very high level description. It's in natural language, so we're not going to use any technological references here. We're going to actually try to describe as best as possible in common terms what the system is going to do, how it's going to implement, how it's going to behave. So we can apply this to our example of a smart home automation system, and would like to actually develop a home automation system that allows the control of lighting in a home. And you want to do this either remotely through a web application. So you're going to log into the web application, and we're going to, manually control lighting in your home. And you're also going to have some sensors in your home that, if you're going to select the behavior mode to be automatic, depending on ambient illumination, they're going to turn on or off lighting in your home. So, for example, if night comes and the light levels are low and the system is set on automatic, they're going to automatically switch on lighting. So you're not going to be, bothered to actually do anything in that situation. So you describe this in the, in this paragraph with the behavior, and you go forward and make a system management requirement. So the system should provide remote monitoring, of course, and control function. You're going to have to do this over a web application. That analysis is, the system should perform local analysis of the data. So there's no, let's say, very intricate analysis of your data. The only thing you need to analyze is actually the sensor data from a sensor, which is going to measure the ambient illumination, and depending on that, you're going to take a decision. So you don't need to have any complex decisions there. Everything can be local. Um, in terms of deployment for the application, you should deploy the application locally on the device, but of course, it should also be accessible remotely through the internet. You can log in from anywhere in the world and actually set on or off your lights, or set the system to manual or to automatic. Of course, there's also a security requirement. The system should have basic user authentication capabilities. It needs those in order to be completely safe from attacks. So in step 2, you're going to define the process specification. Basically, you have these states which you can actually capture in a diagram, and these states are going to give you the behavior of the system through, let's say, the process that you are defining for the application itself. So you're going to have mode, which is going to define how the application behaves. You're going to have, of course, two options here, auto and manual. So if you go through the auto route, you're going to check the light level. And depending on a threshold that you're going to set for the light level, anything lower than that threshold is going to be a low level, and you're going to be in a state where the lights are on. Or if the ambient illumination level is high, then you're going to switch off the light. So you're going to move into a state where it's off. The same thing with manual. Here, you're not going to actually check the light level, but you're going to check a control from your application, which is named light state here. So it's basically user selected. If this control is on, then you, of course, turn on the lights. If it's off, you will turn them off. That's the whole diagram of the system and how the process actually develops for such an application. So it's quite a simple one. Of course, if you want to complicate it, if you want to bring even more states, maybe more sensors, then this diagram can balloon up to an interesting level of complexity. But for now, let's just keep it like this, and it's so it's simple enough. You can follow it during the lecture. Okay, step 3, you're gonna specify the domain model. So here, like I told you, you're gonna be building these UML diagrams where you specify different components of your applications, and then you have different associations between those components. So you have one-way associations, generalizations, and aggregation relationships. And these are mapped through these arrows here, and you can see each of them, each of the types here. And there are different also types of components. So it might be entities, might be services, resources, devices, and attributes. Different colors for and different descriptions for these components as well. So for example, if you have the device itself, so you're gonna probably need something like a mini computer to actually control your IoT application locally. And this mini computer has a light sensor attached to it, and also has an actuator attached to it. The actuator will actually control the lights. So it's a simple relay that turns on or off the lights, and it's a simple LDR sensor, light dependent resistor, to actually get the ambient illumination levels. Then you have two physical entities, which are the room where you're gonna actually employ the system, and the appliance you're gonna you're gonna have the system acting on. The appliance might be the I don't know, the illumination appliance that you have in that room. Then you define two virtual entities that will help you actually deploy the service to. So you have a virtual entity for the room, which relates, of course, to the physical entity of the room, and a virtual appliance. Then you define the service, and the service is actually accessed by the user, which is, of course, might be a human user or an active artifact, which is the app that controls automatically the illumination. So you have basically two users which are actually acting on the service. You have resources. You need basically two resources here. You have a network resource. Of course, you need to connect your system to networks, basically the internet. And then you have an on-device resource, which can work if you set your system in automatic mode, and you don't actually need a network resource in order for the system to actually to work. But it's going to work with some degraded performance. Of course, you're not going to be able to connect to it remotely. So that's, in a gist of it, that's the UML. That's the UML scheme for the domain model specification. As you can see, we haven't actually added any At least until now, we haven't added any technical aspects to it. We're just defining the different entities, services, resources, devices, and attributes, and the links between them. Again, you can go and further complicate this diagram if you want to add more complexity to your application, but that's totally up to the application type. In the next step, we're going to define the information model. So we're going to specify the information model. Here again, we have a diagram where we define the entities that we've described. So we have two virtual entities, basically the room and the light appliance. And of course, the system needs to work ideally with any room and with any light appliances. So we need to uniquely identify each of these. So we can give them an ID for each of them, and then we can give them attributes. For the room, we have an attribute called light level. If it's high, and whether it's high or low, then the system behaves in a different fashion. And then for the light appliance, the attribute will be state, and we will need to measure the state of the appliance. So whether it's on, so the light is on, or the light is off. And that's it for the information model specification. You can use this diagram to go to the next step, where you define the services. So you have the service specifications for each of the two attributes that you've described in a previous step. So you have the light level attribute, which you're going to map, of course, to the light level state in the process specification step. And then you have the state attribute, which you're going to map to the light state in the previous step. So you have you have different services here for these attributes. So let's define them as first the mode service. This one sets the mode to auto or manual, or retrieves the current mode. So if you can actually see or check the state of the system through this service. You have a state service which sets the light appliance to on or off, and retrieves the current light state. Again, you can read through this service how if the light is on or off, and you can set it. And then you have a controller service here, which only acts in automatic mode, and this monitors the light level and switches the light on or off, and updates the status of the status database. In manual mode, this controller service retrieves only the current state from the database and switches the light to on or off, depending on user input. So these are the three services that we are going to need to implement in order for our application to work. It's pretty basic. If there are any questions so far, please let me know. I guess it's pretty straightforward until now. Okay, let's go to the next step then. So you're gonna want to add more details to each of these free services. So for example, for the controller service, you're going to have maybe a native service to implement here, because as you can see here, the controller service runs in the actual application and checks all the time the light level. So you can define further the interfaces for the service. For example, has an input, which is the mode, uh, automatic and manual, and the state on or off. Has a schedule. For example, we can set it to check every 5 seconds for inputs. 5 seconds should be enough to actually update this application in real time, and has an output, which is the state on or off, to denote actually the state of the system. For the for the other service, the mode service. If you remember, the mode service sets the modes to auto or manual or retrieves the current mode. So you're going to have an output which is the current mode, auto and manual or manual. You're going to have an input which is, of course, setting the mode to auto or to manual. And you're going to have a service endpoint through a protocol. So this one, we're going to choose to implement over a REST interface because it's going to have to work over the internet connection. So you're going to have an endpoint you're going to connect to. Let's call it, I don't know, /home/mode. And you're going to connect through an HTTP protocol to actually enable and to have access to the service. And then you're going to also have the state service. The state service here will set the light appliance state to on or off or retrieve the current light state. So you have an output of on or off for the state. You have an input where you measure the state. And then again, we're going to choose to implement it through a REST interface. So you're going to have a, let's say, -home-state endpoint, which is over HTTP as well. Again, this is a purely a design choice. So you can actually implement this over HTTPS, or you can implement it over CoAP or MQTT or whatever. You just need to specify this step, what kind of technology you're going to be using. Okay, next step is the IoT level specification. So here we're going to choose one of those 6 IoT levels that we have described in the previous lecture, and we're going to actually decide which one of those 6 is better suited to our needs. So given that it's a very simple application where we only gonna switch on or off the lights, we can choose the first IoT level. So the simplest one where everything was handled locally. So the monitoring node is local, the database and the services and the application itself is stored locally on that mini computer that we have specified in the previous step. So no complicated designs here. In step 7, we're gonna use these components from the previous step and to map these into the different layers of application services, communication devices, and so on in our systems. So, for example, for the device itself, the IoT device maps to the device functional group. So you're going to have a need for sensors, actuators, and the management functional group. So you're going to need to manage, of course, the device itself. The web services, for example, they map to the services functional group. You're going to have web services which are going to be used in your application, and so on. And then in the next step, you're going to have an operational view specification. So using this diagram now, you're going to specify all the technologies that you're going to use in your application. So for example, for the native service, you're going to have a service called controller service, or you can call it whatever you like. This is going to be running on the mini computer itself. For the web services, we are choosing to use the mode and the state as REST services as we specified. So these are the 3 services that we've defined in a previous step: the state, the mode, and the controller one. For application management, let's use Django for the app management. For the database, let's use MySQL. And for the device management, well, let's choose Raspberry Pi for a mini computer device because it's very accessible and it has all our specification needs. So we're going to use the Raspberry Pi device management application to actually manage it. So for the device itself, Raspberry Pi. For a sensor, we're going to use an LDR, so a light dependent resistor, and we're going to use a relay switch for the actuator itself. Then on the communication side of things, we're going to use REST APIs to communicate. And the protocols that we're going to use are link layer 802.11, IPv4 and IPv6 for the network layer, TCP for transport, and HTTP for the application layer. These are the main protocols that we're going to use in our IoT app. For security, we're going to use the authentication and authorization methods for the web app and for the database, which are native to those two technologies that we're going to use. For the web app, let's use Django as well. Also for the server, and for the database service, let's use MySQL. And that's that. We have mapped all the technologies that are we're gonna use and all the hardware that we need to this simple operational view specification. And step 9, device and component integration. We're gonna specify how the Raspberry Pi computer is going to be linked through, the LDR sensor, the relay, and the actuator itself. That's a very simple, basic schematic. It's easier to follow like this, and these are let's say, the components. Again, it's more at a hobby level in this diagram, but it's easy to follow, I guess. So it's a very simple schematic of how you interconnect the sensor, the relay, and you actually powered the whole contraption. Step 10, you develop the application. So as I told you, it's gonna be a web app, which is gonna allow you to control the light appliance automatically. So you're gonna have an auto mode, which you're gonna set on or off. And if you're in an off state with the auto mode, you can actually control the lighting manually, again through the second control here. A nifty, let's say, visualization trick would be to actually switch to the light state automatically when you are in auto mode. So if the system is in auto mode, the light control here would show you if the light is on or off. And if the auto mode is off, then the light control here will actually allow you to set lighting on or off. And that's pretty much everything that we need for the simple web application. We don't need anything more complicated than this. So at the implementation level, let's map these diagrams that we've set in the previous steps to the web services that we're going to deploy. So we're going to map the services to models, and the model field stores the state on, off, auto, and manual. So you have a mapping here for the mode and the state. And then you write model serializers. These serializers allow complex data, model instances, for example, to be converted to native Python database data types. You can easily render these into JSON objects, for example, or other content types. So you have an abstract specification of your state and your model. In the next step, you write view sets for the model. These combine the logic for a set of related views in a single class. And then in the next step, you write a URL pattern for the services themselves. So see, you write here you actually establish the URL endpoints for your services. If everything works out, you're gonna have, let's say, a REST state API, which will actually allow you to view the states and to set or get or post different commands in your interface. These are two screenshots of the state API and the mode API, and the different methods which are allowed for each. So you can post, you can delete these. That for the controller native service, you can implement it directly in Python on the Raspberry Pi itself. So this is the code for the controller service. You can see it's a very simple code which controls the GPIO pins which are connected to the relay, depending on the state of the LDR sensor or the current mode of execution, if it's set to auto or if it's set to manual. And it's all actually functioning according to this schematic here. The application itself, it's implemented in Django, and you have a view here of how the application itself works. And this is the code, the Django code for the application. This is the template for the graphical user interface. And finally, you integrate the system. So the Django application will rest in the local app storage of your system. Here you deploy it, you test, you run the application, and you set up the database. So you're gonna have an SQLite database which will connect to the REST services and allow to actually check the state of your system or to set the state of the system for interaction to the database. You're gonna have the native controller system implemented in Python. And at the resource level, you're going to have, of course, the operating system, the Linux operating system running on Raspberry Pi, and the device itself. So this is how the different layers, the applications, the services, the databases are mapping to your IoT deployment levels. And that's that. So we have taken an entire view of the process and all the steps. Of course, you can skip some steps if you don't feel like they're necessary. But as I said in the beginning of the lecture, I think it's in order to be very careful of not missing any parts and not missing any steps, you can go through each of them and ensure that you have a complete specification of your process and your system. Now, any questions? Okay. If not, this is the lecture for today.